feel like your stronger suit is algebra.
Yeah, I agree.
Okay. And so over the next 5 or 6 hours, however many we end up doing over the holidays here, we will concentrate on both.
Okay.
And I have a link here to this algebra site that Chad Molina, one of your school counselors, sent to your dad, and so that'll give us plenty of problems on algebra. But I thought where we might start was with vocabulary.
Okay, sure.
Okay? And here's the reason. I want to go through every one of these terms, and every one that you can explain to me, we're going to cross it off, and every one you can't tell me what it is, we're going to highlight it and copy and paste it to a file. Let me open a file here. And every day we'll go over them. By the end of the 6 sessions, you should know what every one means.
Perfect. All right.
What are linear angles?
Linear angles are like two angles that are like
Here, let me draw a couple situations here.
Okay.
Ooh, hold on a second. I got the wrong thing open. This is not what I want to write in. This is here.
All right.
What are linear angles in this diagram?
Do you want me to like give you the numbers or
Any two. You tell me what any 2 linear angles are.
Okay. Let's see here. 5 and 6 would be linear.
Okay. It was actually easier to know that when I didn't do that, huh?
Yeah.
Because that's what you tend to think of when you think of linear pair, is a straight line with another line joining it.
Yeah.
So 5 and 6 are linear, but they're also linear if I do that. That doesn't change anything. Okay? So I feel like you know what linear angles are. Vertical angles. Tell me in this picture, what are vertical angles?
1 and 3, 2 and 4.
Okay.
Just like angles that are on the opposite side of each other.
Whenever you have 2 lines cross, intersect, you always create, that one's the same as that one, and this one is the same as this one.
Okay.
And it's all they have to be is straight lines.
Okay.
So you know what vertical angles and linear angles are. I think he pulled this from the text. What's the difference between a concave and a convex polygon? I'm going to draw.
Concave is when it's like less than 90 degrees, like the angle, right? Because I remember going over this, and then like a convex would be. Yeah, okay, yeah. So like a concave angle is when like one of the angles like caves in on the shape and it's not like an equal polygon, and then a convex is when no sides like cave in and they're like equal angles.
Hold on 1 second.
Okay.
Think have it backwards. But to be truthful with you, I almost never deal with this.
Yeah.
So my terminology is a little bit off. Hold on.
Good.
I hate giving out answers without knowing. I mean, I'd hate to give you wrong information. I think concave is the one on the left. And I think convex is the one on the right.
Okay.
Hold on.
Okay.
No, you had it right.
Okay.
It's the other. I had it wrong. And here's the thing. This is convex. This is concave.
Okay.
And what's the difference between these two?
Concave is when one of the angles like kind of caves in, I guess you could say, on the angle.
Here's the key. Here's the key. In the concave polygon, I can find a point, I can find 2 points, and I can connect them with a straight line, and that straight line passes through the outside of the polygon.
Oh, yeah.
That's the definition of concave.
Okay.
Notice I cannot do this with the convex polygon.
Yeah, no, you can't.
Hold on.
Okay.
I did it wrong. That's great tutor that I'm going to make.
You're going to be fine, don't worry.
The definition is kind of what matters. Notice that in the concave polygon, I cannot find any 2 points that if I connect them with a straight line, that the straight line passes outside of the polygon.
Okay.
That's the definition of concave.
That makes sense.
This is what I thought it was, and then I looked it up in the book, and it said this was what it was, and then I wrote it down wrong. Whereas over here in the convex, I can find 2 points inside that polygon, and I can find lots of them, where when I connect them with a straight line, that straight line passes outside of the polygon.
Okay.
So, let's see if we can figure out a method of memorizing this for both of us.
Okay.
These are the figures that you deal with almost exclusively in geometry, correct?
Yeah.
You almost never deal with convex ones.
No.
In other words, when they're teaching you quadrilaterals or pentagons or heptagons or hexagons, they're always drawing concave. They may not be regular. In other words, what I've drawn here has 1, 2, 3, 4, 5, 6 sides. So it's a hexagon, but it's concave. I don't draw my hexagons like that, even though technically that would be a hexagon. It's just that's not the shapes that they give you when you're studying geometry. You may never run into a convex shape. And if you do, it might look something like this. But, or maybe even like this. And you're going to be able to separate it into 2 triangles. In other words, you are not going to have to deal with convex shapes unless they make up other figures. If I drew a line there, well, now I have maybe a trapezoid and a quadrilateral. So I can deal with it, but you end up almost always having to break up convex shapes into 2 figures.
Yeah, exactly.
So, let's remember it as, what comes first in the alphabet, the C or the V?
The C.
And that's the one we're always dealing with.
Yeah.
So concave. Let's remember concave is the standard polygon that you're looking at. Convex comes later in the alphabet. That's the unusual polygon. The polygon where that you never see. You know.
Sure.
So let me just suggest that as a way of memorizing it. And frequently that I use little tricks like that all the time. I do.
Really?
For memorizing stuff, yeah. And
It's a good technique, yeah.
well, you need to come up with a system. Not all systems work for everybody. In other words, what works for me may not work for you, but you need a system. Whether it's pictorial or based on what comes first in the alphabet or which number comes first, I don't know, but they tend to work. Okay? So, I think we know these first three. I don't need to write any down, although I'm going to put this in my list because both of us got it wrong. So let me copy and paste that. We'll make sure we cover that tomorrow.
Sure.
And we'll just keep covering them until you know them all.
Perfect.
All right. Naming polygons by the number of sides. As long as you know the normal ones.
Yeah.
I wouldn't say that one of the math skills you need is to know what an 11-sided figure is. That to me is ridiculous to make you know that. What's a 5-sided figure?
Polygon.
No, a polygon is a multi-sided figure. So a polygon applies to triangles, quadrilaterals, 6-sided figures, 8-sided figures. That's what polygon means.
Oh, okay.
Okay. Let's look at the ones we're looking at here. What's a hexagon?
6 sides.
Nonagon.
9 sides.
Dodecagon.
Yeah, 12 sides.
Correct. So you know the three biggies. What's a 5-sided? Also happens to be where the headquarters of our national military is in Washington, D.C. What's it called? The Pentagon, exactly. And what does the Pentagon look like from the sky? It is exactly, not only is it 5-sided, but it's a regular 5-sided pentagon. In other words, every angle is the same and every side is the same. My dad was actually stationed there. I graduated from high school from about 20 miles away from the Pentagon. Oxon Hill. And the Pentagon is pretty cool. Not only are there 5 equal sides, there are 5 levels going up, and there's 5 levels going inside. So it is almost like one of those little Russian dolls. Everything is 5-sided. So 5 floors, 5 layers to get to the garden inside, and 5 sides.
Oh, that's cool. I never knew that.
Yeah. And in fact, at the time it was built, it was the largest office building in the world.
Wow.
I don't think it is anymore, but at the time it was.
That is so cool.
What's a 7-sided figure called?
7-sided would be a heptagon.
Good. 8-sided?
Octagon.
Think stop sign.
Yep.
A stop sign is a perfect regular octagon.
Okay.
And I would say that's all the ones you need to know.
Yeah.
What's the definition of a regular polygon?
Definition of regular polygon is when like all sides have the same angle measurement. And then it's like an equal polygon.
Okay. Let's talk about that for a second. Because
Okay.
your terminology is what alerted to me that there's something going on here. If this is a regular pentagon, number 1, all sides are the same.
Yeah.
What about number 2?
All angles are the same.
That's what you want to know. Now, when you first defined it for me, you said all sides have the same, or all sides have the same angle.
Okay.
Okay? And I don't know if that's part of what's going on with you or not, but I've noticed it several times that you have a tendency to get angles and sides mixed up. Okay? And they're very specific. I can measure that side. It might be 1 inch. Okay? That's not even the same units as measuring an angle. If I measure an angle, that might be 100 degrees. So there is a huge difference between sides and angles.
Yeah, definitely.
Okay.
Okay.
I don't think we need to write that down. Just remember that there's 2 things that govern regular polygons. Not just one, there's 2.
Equal sides, equal angles.
Right.
Yeah.
Is this a regular polygon?
That's a rhombus.
Very good. No, it's not a regular polygon. It is a rhombus. And
Please feel free to contact your finance advisor directly with any questions you have regarding survey schedules or concerns.
what is that?
Finance advisor. Thank you for attending with us and have a great day.
Was that your phone going up or mine?
No, that was our home phone going off.
That was your home phone? Oh, okay.
Yeah.
That was just a message being left. Okay.
Okay, yeah.
Okay. So, this is a rhombus. This is also a parallelogram, but it is not a regular pentagon. I mean, it's not a regular polygon even.
Okay.
And it's really hard for me to draw a regular pentagon. Usually, if you try to draw a pentagon and you want to do it precisely, you draw it like a house. But notice a house is not a regular pentagon. That angle is obtuse and that angle is right. So they have different angles. So to draw a regular pentagon, I think each angle needs to be 105 degrees. And that's tough for me to do. Let's see if I can approximate it. There's 105, 105, 105. Nah, I never end up right. It's difficult for me to draw a regular pentagon. It just is.
All good, yeah.
All right.
Okay.
Let's go through more of this list. Midpoint.
Midpoints?
Yeah, here, I'll highlight it.
Oh, yeah.
The word we're on.
Yeah, so midpoints is like what it says. It's like midpoint and 2 sides. I guess
Midpoint is usually referred to of a line segment. In other words, either the midpoint of a line or the midpoint of 2 points. Okay, and it's almost never referred to as the midpoint of an angle. In other words, I would not call that the midpoint of that angle.
No.
That's an angle bisector.
Yeah, exactly.
But it's not a midpoint. If I have a line and there's the midpoint of that line. The midpoint, I guess the way to really properly define it would be it's the point which breaks the line up into 2 equal segments.
Okay.
That's what a midpoint is.
Okay.
And it can be a midpoint between 2 points on a XY curve, an XY graph. In other words, if I want the midpoint between that and that, well, I'm going to create a line and I'm going to find the middle of that line.
Okay.
But when you're dealing with the midpoint between 2 points, then it's actually a little easier. You just have to find the midpoint between the x's and the midpoint between the y's. In other words, you don't need to think of it as being some point on this line that you have to find.
Yeah.
Because all you have to think of it as being is, well, what's halfway between x sub 1 and x sub 2? Let me put some numbers on this. Let me call this minus 5 minus 2. And let me call this plus 3 plus 2. So
Okay.
to find the coordinates on the midpoint, what are they?
So something funny to them. When you just, like, how do you do this?
Couple of ways to do this, and I want you to be familiar with both.
Okay. Can you do, like, how far they are away from 0?
Just draw, I'm sorry, what did you just say?
Can you do, like, how far away the number is from 0?
Well, let's draw it on a number line. In other words, and we're only concerned, if we're going to use a number line to solve this, then we're going to do x's and then we're going to do y's separate.
Oh, okay.
Okay? Well, you want to do that anyway. You want to do them separately. Yeah. But if I'm using a number line to understand it, there's minus 5. That's my x sub 1. Here's 3. That is my x sub 2. I want the halfway point.
Yeah.
Tell me what it is. Conceptually, I don't care how you do it. Just look at that and tell me what number would be halfway between minus 5 and plus 3.
Well, like right between that would be 2. Like negative 2, my bad.
All right. Hold negative 2. Let's check it. Negative 2 is how far away from negative 5?
3 away.
Okay, so that'd be 3, and I got to go 2 to get to that, and I got to do another 3 to get to that. So is negative 2 correct?
Yeah. Well,
it's 3 units away from one number, but it's 5 units away from another number.
Yeah.
So that's not the midpoint.
No.
What is the midpoint?
Negative 1.
Correct. Negative 1 is 4 units from there. It's 1 to there and 3 more to there.
Which is 4. Yeah.
Which is 4. Okay? So, if you're doing it on a number line, that's the way to do it. But you'll notice that that's kind of hard to do.
Okay,
there's a real simple way to do it. That's x sub 1 plus x sub 2 divided by 2. What does that give us in this case?
Just 1.
Gives us negative 1.
Or negative 1, yeah.
Because we have negative 5 plus 3 divided by 2 equals negative 2 over 2 equals negative 1. So we can dispense with the number line entirely.
Yeah.
Let's not use it. Let's just use this.
Yeah.
So when you're talking midpoints, this is huge. And this is going to apply to a midpoint between 2 points. It's going to apply to a midpoint of a line segment. And it actually applies to a midpoint or a mid-segment of a trapezoid. In other words, if that's B1 and that's B2, the mid-segment is B1 plus B2 divided by 2.
That makes sense.
Same thing as that. So midpoints are always the sum of the two numbers divided by 2.
Okay.
And that's the way to do it. And then it eliminates having to picture it on a picture line or anything else. So, what is my midpoint of the y's? In other words, I know the midpoint of the x's is minus 1.
Yeah. So for that one, it would be undefined. Well,
hold on. Do it.
0 over 2.
Don't jump to the answer. This is what I see you do a lot also, is you jump to the answer rather than plugging it into the formula. What is y sub 1 plus y sub 2 divided by 2?
Negative 2 plus 2 is 0.
Okay.
Just 0 divided by 2.
Which is 0, not undefined.
Oh, okay. So
Okay?
it's 2 over 2.
So you were on the right track. You just got confused by if 0 is in the numerator, it's fine.
Okay.
If 0 is in the denominator, it's not fine. It breaks every rule in mathematics. So you cannot divide by 0, but you can divide into 0. So you're fine as long as the numerator is 0.
Okay.
Although when you get to calculus, this is called indeterminate.
Okay.
In fact, I saw a segment on TV yesterday that said this has been one of the more popular questions on Twitter or Google search or something. It's really popular in high school now, is trying to figure out what 0 divided by 0 is. And this is actually indeterminate. It can be all kinds of things. It can indeterminate. And there's lots of things that are indeterminate. Infinity divided by infinity is indeterminate.
Yeah.
But 0 divided by 0 is one of them. That can be 0, that can be infinity, or it can be a number.
Yeah.
And that's why it's called indeterminate, is because we can't determine what it is without further information.
Okay.
Okay? So that's the only case that you can even consider dividing by 0.
Okay. Cool.
It's funny, I just finished reading a book on the illustrated history of mathematics. The last 5,000 years.
Wow.
And what I was shocked is that almost all the math that I know was accomplished by 500 years ago, by 1600. All of the math that has been done between 1600 and today is really high-level, complex, ethereal, conceptually difficult math. But yeah, it occurred to me that I could go back 300 years and I wouldn't be anybody better off than anybody else in that period of time. Whereas, if I was a physicist, that'd make all the difference in the world. They wouldn't know what relative physics or quantum physics was. But with math was really developed, most of it, by 500 years ago.
Wow.
That's when the finishing touches of calculus was being put on. Calculus, there's an interesting story on, just for your information. Probably the most important historical figure in all of math is Sir Isaac Newton, who in 1650 wrote the Principia of Mathematics, which is considered the Bible of math. And he also was the inventor of differential calculus. But he didn't trust it. Differential calculus has these things that get close to 0. They're not 0, but they get really close to 0. And so there's almost a little bit of smoke and mirrors when you study calculus. And he didn't trust it as being correct, so he didn't publish it for 30 years.
Wow.
And somebody else, some guy from Germany came along called Leibniz, who developed the other side of calculus, integral calculus. And they're just inverses of one another, like multiplication is the inverse of division. Well, differential calculus is the inverse of integral calculus. And so here we had two of the greatest mathematicians in history developing opposite sides of essentially the same subject matter. And Leibniz finally published, and then Newton decided, well, he'd publish, and then they spent the next 30 years almost at blows with one another, arguing as to who should get the credit for developing calculus, because 30 years later, calculus was very, very much accepted as a math discipline. And in fact, they now call calculus the greatest math development in the history of the world. It solves more real-life problems than anything else by far, without question, not even close. So that's how important calculus is. And yet, when the greatest mathematician in history discovered it, he wasn't even sure that it was mathematically sound.
Wow.
That's how different calculus is. Calculus is different than anything else. It kind of takes algebra, geometry, and trigonometry and rolls them up into one, combines it with limits, and you end up with calculus.
Wow.
And it's a lot of fun. I hope someday you get to take calculus.
Yeah, definitely. It's just crazy to think of, like, what happened in the past, like, determines, like, what we're doing, like, now.
Not so much. I can give you a real simple explanation of calculus.
Sure, yes.
Differential calculus is figuring out the slope at any point. Let's take those 3 points. Okay? Well, the slope at this point is that, right? And I go up to this point, the slope is steeper. And I go to this point, and the slope is really steep.
Yeah,
well,
sure.
When you talk about the slope in calculus, you're talking about the rate of change of that function at a given point.
Yeah.
Notice that with a straight line, the slope is the same no matter where you're at on the line.
Yeah.
But with a curved line, the slope changes. In other words, the slope changes all over the place when I study this function. And calculus is all about finding out the rate of change at a particular point. What's the rate of change right there? Well, it's the slope of that line. What's the rate of change right there? Well, it's the slope of that line. That's what differential calculus is. Now, integral calculus is also very easy to explain. Integral calculus is merely the area under the curve.
Okay.
In other words, if I said, how would you figure out the area under that curve? Well, you would have no idea because geometry only works with straight lines and certain curved shapes like circles and cones, but they don't tend to work with functions that would graph like this. And yet, one of the real-world life problems is figuring out the area under that curve. We don't have a way, and the only way we have is calculus. And so that's the 2 major areas of calculus. That's integral calculus, which is all about area under the curve, and differential calculus, which is all about instantaneous rate of change. And they were both being discovered completely independently by Newton and Leibniz. And it took them 30 or 40 years before they decided that they were each looking at the opposite side of the coin. And the coin was the key thing. And history credits the discovery or the development of calculus to both Newton and Leibniz. Making them probably the 2 greatest mathematicians in history. But
for sure, yeah. Wow. Cool.
All right. Segment bisector.
Segment bisector is cuts like the segment into 2 equal parts.
Yeah. In other words, the segment bisector breaks the segment into 2 equal parts at a midpoint. Basically.
Yeah.
What's a scalene triangle?
Scalene triangle has 3 equal sides, right? 3 sides at
How often do you hear this term?
Not that often.
Very never.
Yeah.
So it's not 3 equal sides, because that one you deal with a lot, right?
Yeah.
In other words, you're constantly seeing these kind of triangles. What are these called?
Equilateral triangles.
What else is true about equilateral triangle?
The angles are equal.
So it's equilateral and it's also equiangular.
Yeah.
So a scalene is not going to be this.
No.
Because this has its own name. And these names are unique. So if it's not this, the other most common triangle you deal with is called what? What is this called? A right triangle, right?
Yeah.
So what must a scalene triangle be?
2 equal sides.
3 unequal angles.
Oh, 3 unequal.
That's why you never hear about it.
That's true, yeah.
Because there's not much math to be done with 3 unequal angles until you get to trig.
Yeah.
Once you get to trig and you're dealing with trig functions, you might have some usefulness of finding and looking at scalene triangles. But in geometry, you never look at these things. So you use that as a key to memorize it. In other words, what is the thing we don't ever look at are 3 non-equal angles. The other triangle that we're looking at a lot, what's that called?
Isosceles triangle.
Right. These are the 3. These are the 3 that we can do math on. Equilateral, right, and isosceles. Now, it can be right and an isosceles at the same time. In other words, if that side is equal to that side, that's a right isosceles triangle. But in general, these are the only 3 triangles you're going to deal with. And correct me if I'm wrong, but it's rare that you deal with even obtuse triangles. Okay? Where that angle is greater than 90 degrees. And even acute triangles. And as all acute triangles mean is what?
That it's less than 90 degrees, one of the sides.
All 3 sides are less than 90 degrees.
Okay.
So that's acute. Obtuse means what?
More than 90 degrees.
How many sides?
3.
Just 1. You can't have a triangle that has 3 sides more than 90 degrees.
Yeah, they want.
In fact, you can't have a triangle that has 2 sides more than 90 degrees. Why?
They subconnect one.
No? Why? What's the sum of the angles have to be in a triangle?
180.
So it'd be impossible to have 2 angles greater than 90.
Right, yeah.
Because I would exceed 180 instantly.
Yeah.
Okay. Altitude and median.
Okay.
I'm going to draw 2 triangles.
Okay.
Apologize for not being able to draw a straight line.
No problem. Don't worry about it.
One of these is an altitude, one's a median.
Okay. The one on the left would be median, and then the one on the right would be altitude.
Why is this called median?
Because it splits the triangle into 2 equal
No,
parts. Like it splits it in half.
it does not actually. Is all a median is it goes from any vertex to the middle of the opposite side.
Oh, okay.
That's what makes it a median.
Okay.
In other words, if I want to draw a median from here, I find the middle of the opposite side, I draw a line, that's a median. If I want to draw a median from here, I find the middle of the opposite side, and I draw a line. Turns out that all 3 of those will intersect at a point in the middle.
Okay.
But think middle when you think median.
Okay.
Because this altitude does not do that. In other words, that is an altitude. But as all an altitude does is goes from the vertex perpendicular to the opposite side.
Yeah.
So if I did this, and I would make sure that I'm perpendicular, that's a right angle. And if I do this, and I go to the opposite side perpendicularly, those all intersect at the same point also.
Okay.
So these things have meanings other than just, But the key is to remember that the median goes to the middle of the opposite side. Now, there is one particular type of triangle where they are the same thing. And that's an isosceles triangle.
Yeah.
If I go from the vertex and drop an altitude, it happens to go to the middle of the opposite side and make a right angle. So that is both a median and an altitude, and it turns out it's also an angle bisector.
Yeah.
So that's one of the reasons isosceles triangles are special, is that the median is also an altitude, is also an angle bisector.
Okay, cool.
Definition of a rectangle.
Definition of a rectangle.
Mm-hmm.
A rectangle is...
Start it with, how many sides does it have?
It has 4 sides.
So what's it called? What kind of polygon is it?
Quadrilateral.
Okay, so start your definition. It's a quadrilateral. And what else about a rectangle? Let's look at it. Here, let me draw a picture of it, and you can figure it out instantly once I draw a picture of it. There are 2 definitions of a rectangle.
All sides are 90 degrees.
Okay, that's one.
And then, like, the opposite sides are parallel to each other.
Parallel and equal.
And equal, yeah.
So that has to be equal to that and parallel to that. That has to be equal to that and parallel to that.
Okay.
So there's actually, I would say the definition of a rectangle is it's a quadrilateral with opposite, equal, and parallel sides and all 90-degree angles. Okay, and without all of that, you don't really describe a parallelogram. If I were to draw, and in other words, this is also a quadrilateral with opposite sides that are equal and parallel, just like a rectangle. It's exactly the same as the rectangle, except it's missing the 90-degree angles.
Yeah.
There's no 90-degree angles. So the only difference between a rectangle and a parallelogram is the 90-degree angles. You could almost say that a rectangle is a parallelogram with 90-degree angles. That would actually be a shorter way. But that's not really a proper way to define it. Well, because you'd have to know what parallelogram was.
Yeah.
But I guess you could say the same thing about defining it as a quadrilateral. You don't know what quadrilateral is. So I guess the proper definition for rectangle is it is a 4-sided polygon with opposite sides that are equal and parallel, and all 4 angles are 90 degrees.
Okay. Alright, that makes sense.
What happened here? I got it. Oh, went to a different section accidentally. What's a rhombus?
A rhombus it's a quadrilateral, but only the opposite sides are congruent to each other.
What else besides that? You left out, first of all, you left out the most important part of a rhombus. What's the number one thing of a rhombus?
That it adds up to 360 degrees.
No, that's the number one thing of a quadrilateral.
Yeah.
A rhombus, the number one thing is it has 4 equal sides.
Okay.
When I think rhombus, that's what I always think. 4 equal sides.
Okay.
Which, oddly enough, makes it a parallelogram, which I didn't remember. But you can't draw 4 equal sides without making it a parallelogram. Whoops, that's not even correct. In other words, if you try to draw a rhombus that is not a parallelogram, it won't work.
No.
So rhombuses, that's the first thing I know. Second thing I know is that it's a parallelogram. Once I know those two things, then I know everything about it, because I know all about parallelograms. Parallelograms have opposite, equal, and parallel sides, and they're four-sided figures.
Yeah.
It's a trapezoid.
Alright. A trapezoid, so with the trapezoid, the two base angles are congruent to each other.
Hold on. Let's try to define it in the way we're defining these other things, like parallelograms and rhombuses and rectangles. Let's try to define a trapezoid in that manner.
So it's a quadrilateral.
Okay, good.
And then the two base angles, like top and bottom angles.
Let's not talk about the angles yet.
Okay.
What's the most important thing about a trapezoid?
They're congruent to each other.
There are only precisely two sides that are opposite and parallel. They're not congruent.
Yeah.
They're just parallel. The most important thing about a trapezoid is it has two opposite parallel sides, and only two.
Okay.
If that's parallel to that, then it's not a trapezoid, it's a parallelogram. So we have only two opposite parallel sides, and there's nothing congruent here. That's not congruent to that, that's not congruent to that. If it's an isosceles trapezoid, different story. Okay, so what else do we know about a trapezoid? What would be true about these angles? We know nothing about the sides. We can't say anything about the sides. So we can say some things about the angles, though. What's true about 1 and 2?
1 and 2 are, angle 2 is supplementary, like it's more than 90 degrees.
You said the key word, supplementary. 1 and 2 are supplementary. Why? Well, let's draw two parallel lines and let's put a transversal in them.
Okay.
Notice that there's 1, there's 2. Right? They're adjacent. And my parallel lines, they're adjacent. And adjacent angles are supplementary. They add to 180. While when I'm looking at a trapezoid, if I'm looking at just this part of it over here, I'm looking at two parallel lines with adjacent angles. So 1 and 2 have to be supplementary. Okay. Now, do 1 and 4 have any relationship?
1 and 4, no, they don't know.
It'd be tempting to say they're supplementary, but look at how I can draw this thing. I can draw it like that. Well, now they're not supplementary. In fact, I've changed the relationship between 1 and 4 just by changing one side of the trapezoid. Which tells me that there cannot be any fundamental relationship between 1 and 4.
No.
Because I can always, unless it's an isosceles trapezoid, in other words, if I've turned this into an isosceles trapezoid, then I could say 1 is equal to 4. But if it's any kind of trapezoid that's just regular and you don't know anything about it, then I can't say anything about 1 and 4. They clearly are not supplementary because they're both acute.
Exactly,
Okay. And 1 and 3 likewise can't have any relationship because I could have drawn this thing like that, which changes angle 3, doesn't affect angle 1 at all. So a lot of times when you're trying to solve geometry, one way to do it is to see if you can draw it in a different way. In other words, let's say somebody came to you and said, well, 1's equal to 3 because it's a trapezoid. Well, I can change angle 3 really easy. I can make a trapezoid like that where now that's angle 3 and it's clearly not equal to 1. And in fact, it can't have any relationship to 1 because I changed 3 and I didn't change 1.
Yeah, exactly.
Now, 3 and 4 have a relationship that's based on the parallel lines. In other words, 3 and 4 are supplementary. Again, because if I look at just that part, all I have is 2 parallel lines and a transversal, makes those angles adjacent.
Okay. Cool.
All right. Enough for today.
Okay.
That was a good start. I like that start. And
yeah.
We're going to meet again on Sunday at 11 o'clock, same time.
That sounds good, yeah.
Okay,
Am I
Dylan.
seeing you tomorrow?
What's that?
Am I seeing you tomorrow?
Okay. Let me know. I know you guys are going to try to fit in a 6th session.
Okay, sure. Yeah, am I seeing you tomorrow?
I got nothing but time. All for the next 2 weeks.
Okay.
All right, Dylan.
All right. Well, thank you. I appreciate that.
You're welcome. Have a good one. Bye-bye.
All right, you too. Bye-bye.